Lesson 8.2, page 411. State the domain using an inequality, set notation, and interval notation. For any x value excluded from the domain, state whether the graph has a vertical asymptote or a hole at that x value. Use a graphing calculator to check your answer. So we have f of x equals x plus 5 divided by x plus 1. I'm going to use the TI-84 to graph this one. So go here, y equals, and then let's see, math, and I'm going to go here to fraction, and then 1, numerator over denominator, and I got alpha x plus 5 over alpha x plus 1. X plus 5 over x plus 1. Let's check that. X plus 5 over x plus 1. All right. Something I want you to notice. This is x to the first degree, and this is x to the first degree. So the numerator and denominator both have the same degree. So let's graph it, and we'll take a look at it. And there we go. So we need to find out, let's see, state the domain using an inequality. Well, let's look. What is the only number that x does not cover? And an easy way, look, you got a gap somewhere around in here. So let's go to second graph, and there's your table. And we'll go down and look, -2. We got an error at 1 or -1, then 0, 5, and then it keeps on going. Okay. So we're going to say as an inequality, well, we'll use set notation here, domain. Well, inequality, we're going to have x is less than -1 and x is greater than -1. Not or equal to, so that covers all numbers except for -1. Set notation, we're going to have x such that x is not equal to -1. All right. And in interval notation, we're going to have negative infinity to -1 and -1 to positive infinity. Okay. And I'm using parentheses, so it does not include -1. For any x value excluded from the domain, state whether the graph has a vertical asymptote or a hole at the x value. Well, the only place that it doesn't touch is -1. Okay? And that's because you have x plus 1. -1 plus 1 would give you 0, and division is undefined at 0. That's why you get the message error. Okay? So, and if you look at the graph, it does not touch -1 at all. So we have a vertical asymptote. We have a vertical asymptote. negative 1. Okay. Now look at here. We have x squared plus 2x minus 3, x squared minus 4x plus 3. If I was to factor this, let's see here, we're going to have x plus 3 times x minus 1. Here on the bottom, we're going to have x minus 3 and x minus 1. Okay. Now, it's important to do this because this lets you see what's going to happen here in a minute. So let's go up here and let's see. Second x, delete that. Alpha x squared, and we got plus 2x plus 2x minus 3. And then on the bottom, x squared minus 4x plus 3. Make sure I got that right. Okay. Now, notice this is a degree 2 and this is a degree 2. Okay. You are going to have a vertical, let's see, a vertical asymptote at x equals 3, and you're going to have a hole at x equals 1. Okay. Now, remember they both had the same degree. We have 3 minus 3 is 0, and 0 times anything is 0. So that's going to give you your vertical asymptote. Now, these two here will actually cancel out, but it's still in there. Okay? So at 1 minus 1 is 0, and 0 times anything. So that's why you have the hole here. When you have a situation like this right here, you end up with a hole. When you have something like this, you end up with a vertical asymptote. The domain is going to be kind of three-parted here. Let's see here. X is less than 1. 1 is less than x is less than 3, and x is greater than 3. And let's check it. So now that we got that, let's graph it. We'll see, and then when you look at the graph, you think, well, you only got the one here at 3. But if you go to your table, when you notice 1 has an error. And notice between 2 and 4, it goes from being -5 to being +7. Okay? So that's why looking at the graph, you can't tell it. But at 1, there is a hole. There's a hole in the graph. All right, I'm going to close the 84. let's try number 3. Divide the numerator and denominator to write the function in the form f of x equals the quotient plus the remainder over the divisor and determine the function's end behavior. Then, using the graphing calculator to examine the function's graph, state the range using an inequality set notation and interval notation. So number 3 here, we have f of x equals 3x plus 1 divided by x minus 2. So we got x minus 2, and then we've got 3x plus 1. So I'm going to multiply 3x minus 6, and then we're going to, these cancel out. 1 minus negative 6 gives you positive 7. Okay, so that's my remainder. So our new equation is going to be 7 times 1 over x minus 2 plus 3. Now it says divide the numerator by, we did that. And then f of x equals, and determine the function's end behavior. Then, okay, well, what about the end behavior? What can we tell from this right here? Well, a is 7, so it's been vertically stretched by a factor of 7. X minus 2, so h is 2, it's been moved to the right 2, and k is 3, so it's been moved up 3. All right, let's check these two and see if they are equivalent. Control, divide, 3x plus 1 and then x minus 2. And then there we go. And then we'll press tab, and we got 7, open parentheses, and that's 1 over x minus 2 plus 3. And it fell right on top of it. Well, let me show you something here. Menu, 3, 2, and we got y equals 3. And then there we go. So we got a horizontal asymptote at y equals 3. And then we'll press tab, and we got x equals 2. And we have a vertical asymptote at x equals 2. All right. Now, end behavior. As x approaches negative infinity, f of x approaches, it's going to approach 3. As x approaches positive infinity, f of x approaches, again, it approaches 3. Now, what about this in here? As y approaches, as y approaches negative infinity down here, x approaches 2, and as y approaches in positive infinity, x approaches 2. All right. Okay. Then using brackets. Now state the range. Well, the range is the range. What do we got? Y is less than 3 and Y is greater than 3. Interval notation, Y such that, or set notation Y such that Y is not equal to 3. And interval notation, negative infinity to 3. It's unbounded, and then it's 3 to positive infinity. And there we go. And folks, that's all of 3. Number 4. Now, number 4, I need to show you something. So I'm going to multiply out this denominator, x9. That's going to be x squared. x9, that's going to be 3x minus 2x. That's going to give you plus x. And then minus 6. And I did this because I wanted to show you the numerator has a degree of 1 and the denominator has a degree of 2. So it has more in the denominator than it does in the numerator, a higher degree, and it's a degree by 1. But what does this do? Let's see here. Well, let's graph it and see. On new document, no. Let's go to graphs, control, divide, x, and we got x squared plus x minus 6. Okay. Now you notice at 2 and at negative 3 we have vertical asymptotes. So how do we determine the end behavior? As x approaches positive infinity, as x approaches positive infinity, f of x approaches 0. So as x approaches positive infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches 0. Okay, either way. Now, what about holes? There's not any holes. It's actually, this in here works, and you can go Control T and see it. 2, it's undefined. 0 gives you 0. At 3, it's undefined. So the 2 holes are at negative 3 and 2. But what about, we're talking about the range now. Range. Yeah. What range does it cover? Control T. What numbers does it miss? It misses the negative 3 and it misses the 2. But you got, let's see here. You got negative 0.66, and then it's undefined, and 0.5, 1, 0. No, it doesn't miss anything. So on the range, You can just say it's all real numbers. Five. Now this one's a little bit different. This one's a little bit different. Notice you have 2 here and you only have 1 there. So the numerator is a degree more than the denominator, and that's going to change it a little bit. I want to show you something. We got x minus 1, and then you got x squared minus 5x plus 6. So I'm going to multiply x. X times x is x squared. X times -1 is negative x. And let's subtract this. These cancel out. -5 minus -1, that's -5 plus 1. So we got negative 4x plus 6. So we're going to multiply this by -4. -4 times -4x plus 4. And if you subtract that, those will cancel out. And you got 6 minus 4, that gives you 2. Okay. Now, we need this right here because this is going to be really important here in just a second. I'll show you. So now let's graph it. On new document, no, graphs, control, divide, and we'll do x squared minus 5x plus 6. X squared minus 5x plus 6. And then in the denominator, we got x minus 1. X minus 1. Oh, look at here. This is different. Okay, this is very different. You have something called a slant asymptote here, okay? It does not touch this. And remember that little equation that we found? Let's press tab. We found x minus 4. We'll put that in there. X minus 4. There you go. That's where that came in. That's where that came in. We need to find this little spot here. So we're going to go menu 6, 2 for minimum. And so that's going to be -1. And then menu 6, 3 for maximum. Okay. So our range is going to be greater than -0.12 and less than 5.83. Range y is less than less than or equal to 5.83, negative 5.83, negative 5.83, and y is greater than or equal to negative 0. I think it was 172. And let's see, what else were we looking at? The end behavior. The end behavior. Let's take a look at the end behavior. As x approaches positive infinity out here, y, or f of x approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. So let's write that. As x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. Cool. What about number 6 here? What about number 6 here? We've got x squared minus x minus 2. And we got 4x squared minus or plus 0x minus 1. So we're going to put 4 there. 4, that's going to give us 4x squared minus 4x plus 8. That cancels out. 0 minus 8, that's going to be 4x. 1 minus 8, that's going to be minus 9. Okay, so that is our remainder. Now this time we don't have a slant asymptote, and we can recognize it. We can recognize it because this is the same as that. The only time that you have a slant asymptote is when the numerator has a degree 1 more than the denominator, like over here. Okay. So let's graph it. Take a look at it. On new documents, no, in graphs, control, divide. We have 4x squared minus 1. 4x squared minus 1 over x squared plus x minus 2. And that's what it looks like. So as x approaches positive infinity, actually in menu 4, and let's zoom out, see what it looks like. Notice how now it looks like a straight line. It's getting closer and closer to 0 both ways. So as x approaches, actually, let's see here, menu 4, 1, that's, we'll say negative 1,000, and we'll say positive 1,000, and we'll put it at 100. Minimum, because that's kind of messing you up a little bit. Let's see, minimum. We'll say negative 5, and we'll say positive 5. Oh, looky there. So it wasn't actually approaching 0. Menu 3, 2. We'll say y equals 5. So it's not 5. Tab 4. Ha! How can we see that on the equation? So as x approaches positive infinity, f of x, or y, approaches 4. As x approaches negative infinity, f of x approaches 4. Okay? Aren't graphs, graphs are great, ain't they? It says, sketch the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph's slant asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequality, set notation, and interval notation. If your sketch indicates that the function has maximum or minimum values, use a graphing calculator to find those values to the nearest hundredth when determining the range. Folks, I'm just, I want you to be able to graph them in the calculator. Okay, let's see here. So we're going to have on new document, no, graphs, control, divide, and we have x minus 1 over x plus 1, x minus 1 over x plus 1. Okay, that tells you all you need to know. Let's see here if the sketch the graph of the given rational function. So we know that here we're going to have something that's a little high. We know. And then we also know that we have one here. Now, where did I get those from? I got them from the calculator. How can I get them from? Notice here, 1 minus 1, that equals 0, right? So notice it. Y equals 1, okay? It doesn't touch it. Down here, -1 plus 1 equals 0. So on the x-axis, we have -1. All right. On the y-axis, since up here we had +1 and -1. So our graphs are going to look something like this right here. Okay. Also state the function domain and range. So the domain is going to be x such that x is not equal to -1, and range is going to be y such that y is not equal to +1. Okay? Because here you have a horizontal asymptote at y equals 1. You have a vertical asymptote at x equals -1. Number 8. Now, this has, the denominator has a degree of 2 and the numerator has a degree of 1. You've got x minus 1, so you're going to have, let's see, a little. And then over here, you got 2 and -3. So let's find -3 here. And 2. Okay. And let's see, where's going, if I remember right, it'll look something like this right here. And then it's going to do, I may not have that on the exact, but that's the basic gist of the thing. Okay. I think it was supposed to be, that was supposed to go, I think it's supposed to go like this. Maybe if I can, something like that right there. Okay, so let's graph it. On new document, no, oh, new document, no, graphs, control, divide, and we have x minus 1 on the numerator, x minus 1 on the denominator. We have x minus 2, x minus 2, close parentheses, time, and then it was x plus 3. And then we press enter, and there we go. That was closer the first time, it looks like. I was closer the first time. But anyway, you can use your calculator to graph these. Please do. All right, now we've got one with the denominator, the denominator has a degree of 1 and the numerator has a degree of 2. That tells me that there is a slant asymptote. So we got x minus 2. We're going to have something right here. Okay, and I'm not going to worry about the algebra on the slant. Let's just take a look at it. On, new document, no, graphs. We got x plus 1, x minus 1. And then in the numerator, we got x plus 2. And then there's your vertical asymptote. Okay. And you could find that by multiplying the numerator out. That would be x squared minus 1. Yep. And then x plus 2 times x squared plus 0x minus 1. And x, that gives you x squared plus 2x. Negative, it cancels out. That's negative 2x minus 1, so we're going to be minus 2. And so we got x minus 2, tab, x minus 2, and then there you go. And then you would have to find this minimum and that maximum to be able to draw your graph. But you can use your calculator. You can use the trace function on the TI-84. Folks, good job. Thank you very much, and we'll see you soon.